All right, so our next topic is solving real-world examples with inequalities. Okay, so we're solving real-world problems with inequalities. So, aka word problems. With this, our steps are very similar to how they were with equations. So we're going to define our variables. The only thing, instead of writing equations, is we're going to write our inequalities, and then we're going to solve. So inequalities are going to work a little different. Before, with equations, we got one answer and that's it. But with inequalities, it could be a range of answers. So that's going to be our only real difference here. So let's look at the first problem. So Max bought $20 at the arcade, brought $20 to the arcade. Each arcade cost $1.25 to play. He used $6.50 on snacks. We want to know what the greatest number of arcade games he can play. So we have to define our variable. So I'm going to use G for games. Okay. So G for number of arcade games that Max can play. Okay. So we're saying he brought $20. So he can use at most $20. So he can use at most $20. He can't go over 20. So everything that he spends has to be less than $20. And it's $1.25 to play each game. So it's $1.25 G. And he spent $6.50 on snacks. So that's going to be our equation, or our inequality. Okay? So then we just solve for G. So we want to solve for G here. So I'm going to subtract $6.50 on both sides. Okay, I'm going to get 1.25 G is less than or equal to $13.50. So now he can spend at most $13.50 on video games. So then we divide both sides by 1.25 because that's how many each game costs. So we're going to divide both sides by that $1.25. G is going to be 10.8. Okay, so G is at most 10.8 games. Can he play 0.8 of a game? Can he play 0.5 of a game? No, he either has to play the whole game. So he has to pay for either all of the game or none of the game. So when we label our final answer, we're going to say Max can play up to 10 games. We cannot round this to 11. So this cannot be rounded to 11 because we don't have enough money for 11. 11 would be if we had like $20.25 to spend. But he doesn't have that quarter. So we cannot round up to 10, up to 11, but we can leave it at 10. Okay, so this is you're just going to have to be really careful here with the rounding. So looking at example 2, I'm going to start highlighting things. Okay, so we're looking at 3 bins and 2 crates. Yes, I know it says creates. I meant crates. And then we're going to look at this word bin here. So bin, what I mean by this bin in this case is just something that holds stuff. So storage container in general. And the storage container cannot hold anything more than 200 pounds. Now, each crate can hold no more than 50 pounds. So each crate can't hold any more than 50 pounds. And we want to write an inequality and graph all the possible weights. Okay, so I'm going to look at that first sentence. So it says 3 bins and 2 crates. So I'm going to say X is the weight in a bin. And that's what we're looking for. And y is the weight in a crate. Okay, so our first equation should be 3x, so our first inequality, plus 2y. No more than means it's got to be less than or equal to 200 pounds. And then our other one we have is that crates can be no more than 50 pounds either. So we have these two inequalities. And with this y equals 50 here, we can plug that 50 in where we see y up here. So I'm going to do that. So we're going to get 3x plus 2 times 50. 2 times 50. I'm writing this all wrong. I'm sorry. 2 times 50. And then is less than 200. So 3x plus 2 times 50 is less than or equal to 200. And now we can solve, right? This is 3x plus 100. It's less than 200. 3x is less than 100. So x is less than or equal to 33 1/3. So then a bin can only hold up to 33 1/3 weights. Beyond that, it's going to be a closed circle and going to the left, because at most it could hold up to 33, and it goes all the way to 0. Okay, so now I want you to look at example number 3 and try that one. So look at example number 3 and you try. So pause the video now, and then when you're done, check your answer at the end. All right, so now that you're done, we have the 4 consecutive integers. First one, second one, third one, and the fourth one. We added them all up, and they were at most 100, so that's why it's this and 100. You get x is at most 23.5, but an integer is a whole number or a negative whole number. So integers are not fractions. Integers are not decimals or fractions. Not decimals or fractions. So we can't leave it at 23.5, and we can't round up to 24 because it has to be less than that. So then that means that our answer is then 23 for x, and then 24, 25, and 26 are the next consecutive integers. Okay?